Hi guys, this is the last session of Binomial. Welcome. Right, so in this session, we're going to see the applications of the theory that we have learned in the last two videos, that is Binomial Theorem and Multinomial Theorem. We will see about 5-6 problems, what kind of questions actually come in the exam and how do we solve them, right? So that's about me. I'm just skipping this, moving on. Right, so the first two questions. Find the coefficient of x power 6 y square in x plus y whole power 8. We can pause the video and try to get the answer. Now, for those of you who got the answer, let's verify what is the answer that you got and what is the correct answer. Now, if you notice, the basic of binomial theorem, every term should be having x and y some powers. And the other thing is the sum of these powers should be equal to 8. So first verify x power 6 y square. Yes, they are adding up to 8. Now if you remember, the way to write the general term is NCR or NCR minus 1 if you want to write TR, and you write y power r minus 1 because this and this are supposed to be equal, and x to the power of n minus r plus 1 because the sum of the power should be equal to n. So if you remember that, then very simply the coefficient that you want becomes 8c. Now remember, this is x power 6 y square. So you will write this as 2 because this 2 and this 2 are supposed to be same. Okay, simple enough. Straight away the answer is 8c2. The second question is find the constant term in the expansion of x cube plus 1 by x whole power 8. Once again, you can pause the video and try for the answer. Now let us check what the correct answer is. Now in the expansion of x cube plus 1 by x whole power 8, if I want to write a general term TR, this will be of the form 8CR minus 1. Okay, and 1 by x whole to the power of r minus 1 and x cube whole to the power of n minus r plus 1, because this is my a and this is my b in my binomial expansion. So this becomes x power 3n minus so n is anyway 8, so I will write n as 8 directly. So it is 24 plus 3, 27 minus 3r divided by x power r minus 1, which becomes, and there is a 8cr minus 1 also. I'm not writing that, so let me write it 8cr minus 1. So this becomes 8cr minus 1 x to the power of, now bring this to the numerator, so this becomes 28 minus 4r. Now if this term is independent of x, so I'm taking a general term and I'm saying it is independent of x, which means x does not exist. What is the meaning of x not existing? It is the meaning is the power is 0. So 28 minus 4r is equal to 0, or r will be equal to 7. Right? So the seventh term, which term is independent? The seventh term is independent of x. And what is a constant? So it is independent means only the coefficient is left out. Okay, constant term means there is no x in it. That is the whole idea. So it is independent of x. That is what we figured out. So what is left out then if there is no x? Only the constant is there. Constant means 8cr minus 1, which is 8c6. And this is your answer. Okay, let's move on to the next question. Right, so find the coefficient of x square y cube z power 5 in the expansion of x plus y plus z whole power 10. Now this is a direct formula. We know if you want to find x power k1, y power k2 and z power k3 in the expansion of x plus y plus z whole power n, the direct formula for the coefficient is n factorial by k1 factorial into k2 factorial into k3 factorial. So straight away apply that. Answer is 10 factorial by 2 factorial, 3 factorial, 5 factorial. Nothing great. However, if I change this question slightly and if I ask you, find the coefficient of x power 1, y power 8, or rather y power 6 and z power 2. Here, quickly guess what is the answer to this. Pause the video and guess. The correct answer here is 0 is a coefficient. Why is 0 coefficient here? Because this term does not exist in the expansion of x plus y plus z whole power 10. This term does not exist in the expansion of x plus y plus z whole power 10. Why? Because the sum of the powers is only 9. If the sum of the powers is 9, it means the term does not exist. If the term does not exist, technical meaning is its coefficient is 0. Its coefficient is 0. This is a question which has actually come in a couple of competitive exams. You can't blindly apply the formula. Right? Let's look at the next question. Find the number of terms. Again, this is the direct formula here. And the formula is m plus n or n plus m minus 1 c m minus 1. What is this m? M is the number of terms and this is your n. Correct? So the answer here is supposed to be 10 plus 3 minus 1 c 3 minus 1, which is 12 c 2. These many terms are going to be there. All right. Right. Moving on to the next question now. Here, it's an interesting question. Find the number of terms in 1 plus 2x plus x square whole to the power of 10. Now, the problem in this question, or if you try to apply the formula directly saying that, look, this is my a, this is my b, this is my c. So I will write it in the form of a plus b plus c whole power 10. So my answer should be 10 plus 3 minus 1 c 3 minus 1. This is actually wrong. Let us see why it is wrong. Okay. So let us take this a plus b plus c whole power 10 itself. Now definitely one term, one of the terms can be a power 9, b power 0 and c power 1. This term exists. Let's take another term. A power 8, b power 2, c power 0. This term also exists. Now clearly these will be counted separately because in a plus b plus c they are all different. You will definitely count them separately. Now look at what happens if I apply the same term in this expansion. My a power 9 becomes 1 power 9. My b power 0 becomes 2x to the power of 0. And my c power 1 becomes x squared to the power of 1. What is the net effect of this? This is 2x squared. Okay, that is what this term is. Now look at the next term, this example of term, a power 8. A power 8 becomes 1 power 8. B square becomes 2x whole square. And c power 0 becomes x squared to the power of 0. This becomes 4x squared. Now when you have a plus b plus c, you counted these two separately. However, in this 1 plus 2x plus x square, you can't say 2x square is different from 4x square because they actually add up and will give you a single term, 6x square. So you will not count it twice, you will count it only once because it is x square which is common there. So the learning that we need to understand, or the understanding that we need to have, is as long as a, b, c are distinct, there is nothing common between them, then your formula that we learned can be applicable. However, if you have your 2x and x square, now between these two terms clearly x is common. So whenever something is common, there is a chance of the terms getting merged. So you will not have the same number of terms as the formula predicts. So such a question you cannot do by the application of formula. So what do you do then? You will use a little bit of logic in this. What is the logic? Listen, every term will have 1 power something into 2x power something into x squared to the power of something. Correct? such that the sum of the powers is equal to 10 and there will be a coefficient, some big coefficient. This much is clear. Now, what is the least power of x you can have in this? The least power of x you can have when 1 is raised to the power of 10, 2x is raised to the power of 0, and x square is raised to the power of 0. This becomes 1. This is the least power. What is the maximum power of x you can have? When you want maximum power of x, you put 0 to the 1 to the power of 0. You give 0 to this 2x also, but you give all 10 over here. You will get this as x power 20. So you look at a term, one term is single without x, the other term is x power 20. You cannot go beyond x power 20, you just saw, which means the terms that you are having will be between x power 0 to x power 20. At most, they can be 21 terms. They can be 21 terms. Now the question is it possible for me to get all my 21 terms? So which means, can I get x power 1? Can I get x power 1? Right? Yes, you can. How will you get x power 1? You put 1 power 1, 1 power 0, or rather 1 power 9, 2x to the power of 1, and you keep x square to the power of 0. So total adds up to 10, the powers, and this becomes 2x. So yes, x power 1 is possible. Similarly, you will see x power 2, is it possible? X power 3, is it possible? So it's a little bit lengthy and complicated, but if you know the basics of numbers, you'll realize that when you have something as x power 1 and x power 2, so basically you are adding powers of 1 and powers of 2, definitely all numbers up to 20 are possible. Let's take 19. How do you get 19? I will take x square whole power 9 and I will take 2x whole power 1 and 1 power 0. So 0 plus 1 plus 9 is 10, and you will basically get this as 2x to the power of 19. So like this, all terms are possible from 0 to 21. So all 21 terms exist. So the answer here is 21. Now in some cases, in fact, the next question is that it is not possible for you to get all the terms. So your job will be to figure out which terms are not possible and subtract those many from 21 or whatever the total number of terms possible are. Right? So let's take an example and see how that kind of a question comes into play. So if I take the next question, here it is 1 plus x cubed whole power 10. Now here, if I am looking at 1 plus x cubed whole power 10, I will compare it with a plus b plus c whole power 10. Now, if I will write a power k1 into b power k2 into c power k3, right? Now clearly k1 plus k2 plus k3 should be equal to 10. So this is how the terms will look. If I write it in this, for this, the term will look like 1 power k1 into x power k2 into x cubed to the power of k3. So this will result in x power k2 plus 3k3. Correct? Because that is a simplified version. Now keep in mind, here also we need k1 plus k2 plus k3 equal to 10. You can't go less than this or more than this. Exactly, the k1, k2, k3 should be equal to 10. Now what is the minimum power of x? Minimum power of x is x power 0. How do you get this? When you make these two zeros and you make this 10, which means you will get 1 power 10, x power 0 and x cubed to the power of 0. Because remember, this is 1 to the power of k, this becomes x to the power of k2, so this is k1, and this becomes x cubed to the power of k3. So if k1 is 10, k2 is 0, k3 is 0, the resultant is x power 0, which is a constant. What is the highest you can go? The highest is when these two are zeros and this is 10. So what is the highest value? Highest value becomes x cubed whole to the power of 10, which is x power 30. So the number of terms possible I'm not saying they exist, so many terms exist. The highest maximum possible terms you can have is x power 0 to x power 30, which is 31 terms. Now, you know, your job is to figure out which of these terms is not possible. Can you get x power 1? Can you get x power 2? Can you get x power 3? Like this, you have to check for can you get up to x power 30. Now, you can see that x power 1 is possible because you basically looking at x power k2 plus 3k3. This is what you're looking at, k2 plus 3k3. What all are possible using this? Can you get it 1? Yes. You put k3 as 0, k2 as 1. The remaining is k1, right? So if k3 is 0, k2 is 1, then k1 I'm writing here, k1 will become 9, so that the sum of them is 10. Now, can you get this as 2? Yes. You put this 0, k3 as 0, right? K3 equal to 0, and you put k2 equal to 2, right? And automatically k1 will become equal to 8. So this total can become equal to 2. So quickly, let me write down a small neat table for you to understand exactly what is happening once again. I'm making it a bit more clearer. Okay, so you have k1 value, you have k2 value, you have k3 value, and the resultant will be k2 plus 3k3. So if you want this total to become 1, you will put this 0, you will put this 1, and the remaining will be 9, because remember, these total should always be equal to 10. Similarly, if you want this to be 2, then you'll put 0, you'll put 1, and you will put 9, you'll put 2 and you'll put 8, which will give you total 10 again. You can also get this 2, you can get in, you can get then, the next thing is 3. The 3, you can again put 1 here, 0 here, and 9 here. Total is 10. You can get 3 in 2 ways. You can get 3 like this. You can also get 3 by putting 0, 3, and 7. Right? So the total is 10. So like this, you will realize that 1, 2, 3, 4, everything is possible up to the only number, in fact, that is not possible is 29. Because if you want 29, look at how is it possible? K2 plus 3k3 should become 29. So if you put this as 8 3s are 24, then this will become 24, then you need 6 here, right? So it is not possible, you need 5 here. So the total is crossing 10. The other way, if it is not 8 and 5, let's put 9. Let's put 9. If you put K3 as 9, 9 3s are 27, then K2 should become 2. Again, you're crossing your 11. So 29 is not possible at all. So out of these total 31 possibilities, 129 we figured out is not possible. Similarly, check for 28. Is 28 possible? Just check. 28. How do you get 28? Yes, this is possible. You put 9 here, you put 1 here. Total is 10, and 9 3s are 27. Right? K2 plus 3k3. So it is 1 plus 27. 28 is possible. So you will realize that only 29 is not possible. So out of 31 terms, one term x power 29 is not existing. So you will get totally 30 terms. So this kind of a question becomes a little bit lengthy for you to solve because you have to check which of these are possible. A small hint, usually check the first few terms and check the last few terms. If at all there is a problem, they will exist in the first few and the last few only. You don't have to check for everything, right? So friends, with that, we will end binomial theorem. These are the type of questions that can exist. Oh, by the way, one last thing. If you need to find any coefficient in this, if you need to find, let us say if I ask you to find the coefficient of x power, let's say 4, x power 4. Now, how do I get x power 4? I can get, so look at all the ways in which you can get x power 4. I can get x power 4 directly like this. X power 4 into x cube power 0, which means this will become 6. Or you can get x power 4 as 1 power x power 0 and sorry, not 0, x power 1 and x cube whole to the power of 1, which means 1 power will be 8. Is there any other way? I don't think so. These are the only two ways in which, oh, there's one more way. I can write x power 4. Okay, no, that's I think these are the only two ways, right? X power 4 directly and x power. So this is x power 4 directly, this is x power 1, and the other terms will adjust accordingly. Okay, so these are the only two ways. Now this basically means this is your k1, this is your k2, and this is your k3. So the coefficient of this term is 10 factorial by 6 factorial into 4 factorial. The coefficient of this term is 10 factorial by 8 factorial into 1 factorial and 1 factorial. I'm not writing that. But because both of them are x power 4s, they will get added. So your net coefficient will be 10 factorial by 6 factorial into 4 factorial plus 10 factorial by 8 factorial. This will be your final answer. Please keep that in mind. You can't use the formula directly. You can't use the formula directly. Right? So, well, with this, we will end binomial theorem, friends. I hope you enjoyed the 3 basic sessions. See you in the next session.